All right, everybody, we're going to go ahead and get going today. We've got Grace Hunt and Micah Stratton presenting, and I'll let Grace get on into it.
Sure. Thank you guys. I'm excited to be here for my first journal club presentation. Let me turn on my mic. I'm a postdoc in the TRT program, and I work at the HGN lab for bionic engineering. And my paper that I'm reviewing today is about occupational exoskeletons and how they get to large-scale adoption in real industry. So first of all, I wanted to talk about why I picked this study. So in the lab that I work in with these guys right here, we make wearable robotics. And during my PhD, I worked mostly with prosthetics, which is basically all rehabilitation because you don't use a prosthetic unless you've had an amputation for the most part. We also, I don't make them. Other people in my lab make really awesome exoskeletons that you can see here. And those can be used for both rehabilitation and occupational. And we're kind of moving into occupational spaces more recently. So this paper is a little in my wheelhouse and a little out of my wheelhouse, which is probably exactly where I wanted it to be. Let's see. So another interest of mine is just robots in the workplace and in life generally, whether that means one of these guys in the grocery store that looks for spills and vacuum stuff and alerts employees if something falls off the shelf, whether that is like what you would call a cobot, where you're kind of manufacturing something alongside a robot, or if it's an Amazon factory robot where it just follows you around and carries heavy stuff. You can just like put heavy stuff on it and it will move it around the warehouse. I just think these are really interesting. Along with exoskeletons, you have to figure out when it interacts with the person, how are you going to control it? How are you going to make it safe? What should it do? How do you make people trust it? In order to adopt technologies, we have to have them be kind of predictable and safe, and the people who actually interact with it need to enjoy interacting with it for it to work. I'm also interested in translating research from the laboratory to the real world, and it's a hard thing to do. We try and make our research as translatable as possible, but it would still be hard to take one of our exoskeletons and give it to a car manufacturer and just have it work immediately. There's definitely some transition from research devices to occupational devices that you'd actually buy and use in real life. So the purpose of the study, they did 4 different things. They first looked at the state of the art of occupational exoskeleton research in 2021. They looked at laboratory and field studies. They looked at the methods of assessing effectiveness of these exoskeletons that were used in each of the studies. And then they presented a roadmap to large-scale adoption of exoskeletons. And this is a review study, kind of. It's not the best review that has ever been done, I'll say that. Their methodology for actually reviewing the papers, I'm not super hyped about it, but that's fine. It is a pretty good paper in other ways. So first of all, starting off with the definition, this is how the paper defines it. They define occupational exoskeletons as personal assistive devices that can reduce the load on workers, support specific body parts, or augment specific human capabilities. So here are a couple of them down here. And this study actually, they only looked at back and upper exoskeletons. So this one over on the side was not in the study, but it's one that I like. I'll talk about it a little more later. But this is our definition. And so what does that actually look like? It can look like allowing you to do more, lift more weight. It can reduce the effort that you need to put in for a specific task. It can improve your performance or accuracy. It can allow you to do the same thing for longer. It could allow you to do something more comfortably, especially in this paper, they really focused on upper limb, like car stuff. So if you're in a weird, awkward position, it could be really nice to have something supporting your arms in that position. Can reduce your fatigue, prevent injuries, whether that means overuse or like an overexertion, or even preventing your joints from going, from collapsing, going the wrong way, potentially. And then these were some that were not in the paper, but just a couple that I was thinking about as well. So you could use an exoskeleton to encourage ergonomic postures or movement. I was kind of thinking if I used an exoskeleton in my job where I just mostly type, maybe It could be one that prevents me from ending up like this at the end of the day. That would be a good exoskeleton for me. You can also theoretically record and assess performance using the exoskeleton. So it could also be a device that you use to monitor the employees. So there's some maybe privacy concerns. Okay. So the first area of this paper, they just kind of classified exoskeletons and gave a good overview. And the first classification was based on kinematic structure, which is important because the structure of the exoskeleton determines how well it can transfer assistance to the person. So it's basically, how is this robot actually, like, is it a rigid robot? Is it a soft robot? And does it look like a person shape, or does it not look like a person shape? So let's look at these. Anthropomorphic first are human-shaped rigid robots. So these have joints, and the joints need to be aligned with the human joints during the whole movement, which is really difficult. So our human joints are not perfect hinges, and the moment or the area where they rotate can move as you actually perform a movement. So they're not necessarily static position either. And we usually compensate for this by using what's called a passive degree of freedom, which is basically just like an extra joint that can allow the robot to move around the person and prevent the robot from hurting the person in kind of off-axis directions usually. Now, you can also solve this problem using non-anthropomorphic designs. So if you don't have a direct correspondence between the human and exoskeleton joints, you don't have to align them perfectly. But it may be like less intuitive to design and control a robot that doesn't look like a person to follow human movements. And it looks funny. If you're wearing that at work, it's going to be a lot more obvious that you're wearing a robot. And then finally, the soft exosuits are more like clothing. So these are soft, they're not rigid, they don't have rotating joints, and they usually work by pulling on cables and fabrics in the same way that muscles and tendons work. The next classification that they give us is the actuation type. So is the robot passive, which means it cannot produce energy. It only will use rigid structures, springs, and dampers. So it can store and return energy or dissipate energy, cannot inject energy. These are usually more common in real industry because they don't have motors, you don't need to control them, and they're probably on the safer side because they're just predictable and intuitive. It's not a robot. It's just something like stretchy or springy or supportive. Semi-active is partway in between, where you have small motors that change the passive behavior of the device. For example, changing the stiffness of a spring. And then finally, this is what I usually think of when I think of an exoskeleton, a fully powered device, where you have an electric motor usually that is actually generating torques. And you need to control it. So you need to have sensors in the device, and you need to have controllers that can actually change the way the exo moves with the person. This can be more adaptable in theory, but you have to write controllers for every adaptable movement that you would want to use. And it can be scary because the robot may not be predictable. The controller may not work exactly how you're expecting. This is one that I added. And to give them some credit, they're only looking at upper body, so this doesn't have a super big application, but this is a big one in my mind when I think about occupational exoskeletons, is whether or not the robot is bearing the weight. So in a robot like this, which is the Sarcos Guardian robot, this was developed in Salt Lake City. They recently stopped making robots, very sad. But these, you could lift 400 pounds without it being very hard because the robot is actually bearing all the weight that you're lifting. Whereas the other type, non-weight bearing, is just more supportive, so you can add extra torque to people's joints, but you're not going to exceed a person's normal ability by a big margin. Okay, so the methods of this paper, they searched for papers looking for objective and subjective evaluations in the laboratory or the field, active and passive devices, only back support, and upper limb devices. And they didn't list, you don't see a tree for how they actually narrowed down the choices of papers. Just a little disappointing. But They selected 99 papers and they wrote a really nice summary of all of them. So here's one of their first results where they're just overviewing the papers that they found and the types of data collections that they did to evaluate these exoskeletons. So they split it up by back support and upper limb, and then by laboratory and field studies, and the colors correspond with the instrumentation that they were using. So the most common instrumentation was muscle activity. So that's EMG sensors that show how hard you're contracting a muscle. And then the next biggest was perceptive scale. And I think that's just because it's a big bin. You know, anything that is a scale that's not one of these specific scales went in the scale category. So it is big. They also double counted. So like, let me put these guys up. So this is the number of studies in each category. You can see there are six bars here and 5 studies. So if a study used multiple types of evaluation, they listed them under all the categories. So that's a little misleading to me, but this is interesting. So then they kind of talked about like the overall, a lab study and a field study. So they were talking about how lab studies, you're generally looking to validate the exoskeleton. If you want to look at the biomechanical effects, like what are the joint torques while this person's using an exoskeleton, for example. And you want to demonstrate the fundamental abilities of the exoskeleton and potentially identify dangers, like if you're offloading one joint but putting more stress on a different joint. Whereas field studies are more focused on the effects on the actual work, on the people in the workplace. So how well is it accepted? How well does it perform? How does it actually affect the work? And part of that is because of the methods that they use. So if you imagine a laboratory, big open room, flat floor, there's force plates in the floor, there's cameras everywhere. That's not what most workplaces look like, right? But you can use much more precise equipment, way more equipment, you know, a lot of stuff that you couldn't really get into the field. And using motion capture cameras and force plates, you can actually calculate the internal moments at each of the person's joints or torques. Moments and torques are the same. And so that can be really interesting. And you can't really do that in the field because you can't put force plates in like a car shop, right? But so most of the time in the field, they're using wearables, surveys, subjective feedback, and sometimes the outcomes are like ability to complete a task. So there's some pros and cons. For lab studies, they talked about how it's constrained, so you have less variability. That's a pro and a con, in my opinion. Research doesn't like variability, but if you want to translate to the real world, variability is probably good. You want to be able to adapt to that. And then for field studies, these are usually going to be more realistic, but less like precise. It's a difficult place to do an experiment, and you generally have worse equipment. Here are a couple of examples of the scales that they use to evaluate this type of a device in an actual work scenario. I just thought this was kind of interesting. This is one that we use in our work, basically just asking, you know, mark on this scale somewhere how you feel. And you would complete this one like with and without the exoskeleton. Whereas that one is more about using a new product in an actual work environment. I'd never seen this before, and I like it. Okay, I also just wanted to point out a couple of these, the results. This is just interesting. I like seeing what kind of studies people do. So snow shoveling as fast as possible until fatigued. Order pickers of cheese with low back pain. And then we have 9 workers finishing a catamaran hull. So these field studies are super interesting and super specific. And it kind of highlights the difficulty of writing this type of a paper where every single study is just super, super unique. They also did a stakeholder evaluation, which I hadn't seen before, but I thought it was interesting. So there's just a couple of examples. So workers, they're more interested in how is this actually going to change my specific job, which makes sense. And they may be more influenced by, you know, firsthand user experience, trying it out. Whereas and ergonomist, I don't know how to say that, kinesiologists, occupational medical doctors, they're more interested in, how is it going to fit into our existing structures for mitigating workplace risks. And a corporate management would probably be more interested in like the pros and cons on the big picture of, the workplace and the company. So this was interesting to me. I think it's a good kind of a zoom out. They're obviously not writing this for just researchers, which I appreciate. And, oh, wrong way. And then they had this roadmap, which, the actual organization of the roadmap is a little confusing, but they have some good stuff on here that I hadn't really thought about. Like, if you're using an exoskeleton and you want to take it to the workplace, you definitely need to figure out where you're going to store the device and how you're going to maintenance it. So they do like really zoom out and give us a good view of like, if you were a CEO, what's everything you have to worry about? I like that. Okay, so some strengths and weaknesses. I thought they did a pretty good overview of exoskeletons, and they did a good literature review of these papers. They looked at like past, present, and future perspectives. They looked at lab and field. They included passive devices, which I put in strengths. In this situation, I think it is a strength because it is way more common in real industry and probably way easier to translate those type of devices. They had a really broad scope, and I like the stakeholder analysis. On the weakness side, they never described like what does it mean to be occupational. If you look at some of these studies, it's like walk on a treadmill for 5 minutes. That's not occupational, in my opinion. They didn't list their inclusion and exclusion criteria, and they didn't explain their data analysis. The longer I look at figure 3, the less it makes sense. I'll give you $5 if you can tell me what they're trying to say. Just kidding. I don't have $5 right now in my pocket. So then they also only considered back and upper limb exoskeletons, which in my opinion, they should have looked a lot more at lower limb too. And they don't make a distinction between research and commercial devices. So this isn't the same as lab and field. You can take a commercial device and do a lab study and a commercial device and do a field study, right? And when I looked at the actual devices that they were using in these studies, it was pretty different. So here are some examples of research devices that they looked at. These would be pretty hard to use in an actual workplace. They look really complicated. They're obviously still at like an early stage of development. You couldn't buy this off the rack and start using it, right? Whereas these are some of the commercially available ones that they were looking at. And these are a lot more simple. It's obviously been through more of like a development process, and you could actually buy it. So this is not the most important distinction, but I think it's worth thinking about. And I would have been interested in looking at the results stratified by research and commercial devices. And here's AI hates exoskeletons. They refuse to put robots on the outside of people. So we have robot. I asked them to make it more human. They gave him some backwards baseball caps. That firefighter one is the closest that it actually got, in my opinion. This was fun. And then here's some questions that I had for you guys. So I'll actually ask the first one. Raise your hand if you've interacted with a robot. You guys are cheating. Put your hands down. But like a Roomba, this morning my Roomba was stuck in the kitchen. So that's a robot, I'm pretty sure. Someone else? Yeah. What other robots have you guys interacted with? And what was it like?
I was doing a study in a construction site, and they have one of those Elon Musk dog things going around taking pictures, like 360 pictures, so that the people don't have to do it and keep track of progress, which I thought was interesting. But then all of their like safety indications were at human height, so like the dog ended up like walking through wet concrete and see the safety signs. So.
Wow.
Yeah.
That's an incredible example. Thank you. Anyone else interacted with a robot in real life? Well, do you guys have questions? You'd also answer some more of my questions. Who would rather wear a robot And who would rather work alongside a robot? Would you rather wear an exoskeleton at work? Raise your hand. Cool. Yeah.
We should be listening to the subject matter experts. Is that because you view robots as more hazardous than an exoskeleton?
No, because when you wear it, you're in charge. No, I'm just kidding.
Control
I
is important for well-being.
I do think a little bit when you are wearing an exoskeleton, oftentimes you have a controller which might perhaps like, turn off if you're trying to like do something very quickly, right? Or they're designed in a way to get out of your way, or I think if you're working alongside of a robot, it maybe has more of a preference to be in your way or doing the task or being in the space that you'd like to be in.
And wearing the robot might just have more direct benefit to you. Like if it's able to actually help me complete the task as opposed to completing it for me.
Yeah, stealing your job.
Yeah, it's maybe not what I want.
I don't have direct experience with robots, but when I was Oregon's occupational fatality surveillance program director, at our national meeting, they had fatal incidents involving autonomous forklift trucks. And,
Yeah, that sounds really scary.
it was a problem of sensors getting covered or interfered with, and so the machine didn't see worker.
Yeah.
And so they can be dangerous if they are compromised.
Yeah, totally. I think like with any with any robot that a person might interact with, you just have to have crazy safety precautions. I like the ones in the grocery store because like as soon as they see you, they just stop. Yes.
I went to a restaurant in LA that had, instead of servers, it was the robot.
That's
And
cool.
I thought it was horrible. 'Cause
Oh.
I'm like, I need another one. I need.
Yeah.
My answer, in Taipei, there was a dish collector robot roaming around.
Oh, and that's, but if you're like eating something, it was not.
Not helpful.
helpful.
That makes sense. Cool. Yeah.
Also, like self-driving cars or autonomous vehicles, they're like kind of like robots.
Yeah.
There's a ton of problems with that.
Yeah.
They
Yeah,
say
is a Tesla a robot?
way. They've got a lot to figure out.
For sure. Yeah, I feel like we're super far away, but also I expected robots to be more prevalent by now. Yes.
As far as barriers, the thing that I always think about, like the construction guys I know,
Yeah.
it's like you can't get these guys to stop pinning back the safeties on their nail guns, removing the guards from their saws.
Yeah.
Like,
So you just think like acceptance would be a really big problem.
yeah, and I mean, I know that's kind of different because like it's more, you're more likely to kind of be able to implement that sort of acceptance of like among the good actors in the industry
Yeah.
already, and they're going to be the people looking at this anyway. But I mean, there are all these cultural issues that kind of go up and down different occupations that can kind of.
Totally. And just like trusting the robot, trusting the person who made the robot, trusting your boss not to spy on you with the robot. Yeah.
On the trust issue at an autonomous vehicles workshop I went to, there was, I think he was at the U of M, a human factors researcher,
Mm-hmm.
and he said for us to be accepting of robots from a safety perspective, they have to be thousands of times safer than a human
Yeah.
rather than just 5 times safer. So our mistrust of machines is fairly high.
Yeah.
So the safety performance of robots has to be very high for us to feel safe, even though they may be already 5 times safer than us.
Yeah. I was thinking about that when you said the forklift thing. Like, I'm sure so many humans have killed other humans with forklifts, but
Oh, it's a very
You don't
common
hear about that.
deadly machine.
yeah, it is way scarier if there's no human driving it, undeniably. Yeah.
When I worked in like a production plant that did like manufacturing and all that, all the robots were kept behind like glass.
Mm-hmm.
Well, it wasn't glass, it was plastic, like plexiglass.
So you just like can't
and-
interact with them.
You can interact with them, and if you do like to like maintenance them, you have to use like lockout tag out where you
Mhm.
like fully power down the entire module. So you're not in danger of it hitting you because it does not care.
Yeah.
Like it will just smack you.
That
Like,
makes
even
sense.
in like the distribution center, like the like sorting and like bigger robots, they were also just completely segregated.
I like that.
Acrylic.
Yeah. But not an option with exos. Yeah.
This might be a really convoluted question, but is there any research on like the long-term effects of wearing a fully motorized exoskeleton? Because I wonder if there's maybe like a consequence of like muscle atrophy, and then if
Yeah.
the exoskeleton all of a sudden doesn't work that day, like, and you have to do it yourself, are you actually at more risk for injuring yourself than you would have been otherwise?
Yeah, so there are no like really long-term studies yet. But that's a huge concern with rehabilitation robots as well. Like if you help someone, are you making their condition worse by like, helping them too much? Yeah.
One comparison point to consider would be studies on astronauts. So
Yeah.
coming from a weightless environment and being up there for a longer period of time, they've done quite a bit of, these are case studies because we don't have that many astronauts, right?
Yeah.
But regardless, there's pretty good evidence of the atrophy and other things that happen because they don't have to lift their bodies.
Yeah.
The gravity's not there. And so that can provide some indication of what would happen if a person was in an exoskeleton and it was doing all of the effort, all of.
Yeah. Even just a passive one, holding your arms up, and then
Yeah.
one day you have to hold your own arms up all day.
All day, yeah.
Well, I also think like another analogy which I really like is like an e-bike. So you see a lot of people buy
Yeah.
e-bikes, and then these people end up biking more and taking more hours. And so if an exoskeleton is simply just replacing the movement for someone, I think there is maybe you could be concerned about atrophy. But oftentimes, particularly in occupational exoskeletons, we see is we're actually augmenting. So people may be using, maybe they're lifting more, but every lift is takes less effort. And so because of that, you're actually maintaining some of that,
Yeah.
muscle use.
Yes.
Yeah.
A question from Claudia online. She's asking a little bit about the methodology. Did they mention the search terms and the databases that they use?
Nope.
Oh, that's interesting.
It is interesting.
That might be another term.
Questionable. I agree. Yeah. Yeah. I totally agree with that. I was pretty disappointed in that, honestly, once I looked closer. Because I was, what do you count as occupational? Just like whatever they want, I guess. Yeah. Any other questions?
Anything else? Going once, going twice. All right, great job.
Surveillance thing. Surveillance thing has me thinking.
What? Yeah.
How much?
Use of our technology.
There's somebody out there who's gonna be like, oh, we're gonna put motorized exoskeleton. Now I think I don't know, but because we can real time production.
Yeah, but
Or at risk.
Should just have both like that.
I think it was a.
Someone's
On the
talking too long. Slow.
The truck drivers done by Virginia Tech and
That'd be
they were
hilarious.
supposed to be field testing that
Keep it.
had.
Under 5 minutes or you're gone.
And you get the driver.
Like,
Even
drive the
though
ones
they're
that-
involved in the study, I'll take over the camera. It's like, I learned after.
Show it
that,
all on how to do it.
Yeah, you can do like no authoritarian. And that's not And so they were just like. And so that the study has almost no data on camera. Only on feedback on actual driving. You can start.
Hi, I'm Micah. I'm a master's student in the OIP program, and I'm really excited to be here today and talk about a study of diurnal cortisol adaptations in sleep-deprived firefighters during a 72-hour work shift, a case series. Just a kind of a fun fact about the article. This was a master's level thesis. And this study was completely funded by the author, Neil Sundberg. Did it for the love of the game. The motivation for this study is really centered around the hypothalamic pituitary adrenal axis. And so these structures in your brain, in your body, work together to modulate your physiological stress response. Something stressful happens in your environment, your body perceives that stress. These structures respond through a cascade of hormones to adjust and prepare your body to physically respond to the stress. So this looks like heart rate variability, increasing or decreasing blood pressure, and then the release of hormones like adrenaline and cortisol, sort of those really common markers for stress in the body. Now, the idea or the interest of this HPA axis is that it's well known in medical literature that prolonged or intense stress can cause dysregulation in this process. So you go through this process too intensely or too often, and you can start to see dysregulation that leads to various diseases like cardiovascular disease, metabolic disease, and behavioral disease like suicidality or suicide. So that gives us sort of on one side of the coin, we've got this stress response, a change or a maladaptation in the stress response causes disease. And on the other hand, we've got this population of people who work in extreme stress environments and have a lot of those same cardiovascular, metabolic, and behavioral diseases that were mentioned that can cause from a maladapted HPA axis. So where's the link, right? This paper is trying to address that link by looking at salivary cortisol levels as well as a few other biomarkers in this population in a small group of firefighters to say, where's the plausibility or the possibility that we can, for one, get an idea of how much stress is happening in this population and how that might affect their disease rates. So let's take a look really quickly at a little bit of a dive into the cortisol response. What this graph is showing is sort of like a normal physiological value of cortisol in your body throughout the day. There's a really large spike right here within 30 minutes of waking up, referred to as the CAR or the cortisol awakening response. And then after you have that event in the morning, it's kind of a general steady decline towards the evening, and the cycle repeats all over again. Now, we'll come back to this slide after talking about how they reported and how they measured the cortisol, but this is sort of the baseline and traditional way that cortisol values are thought of or measured. Our population. So there were 5 firefighters that they used in the study. That is why it's a case series, small population. Again, another fun fact, this is the author's crew. The author worked with this crew for about 5 years as a professional firefighter in Southern California, and then left to work in academia. So kind of returned to his crew and did this study with them. So as you can see, the age range is from about 20 to 40, and you'll see that they're really kind of focused on classifying their obesity levels. They did do some baseline demographics, hip to weight ratios, BMIs, sort of traditional biometric assessments. But the thought in this paper was to say, okay, on a national level, we have 70% obesity in firefighter. And they were sort of suggesting that maybe this rate of obesity is a sign or symptom of dysregulation overall in HPA axis, seeing obesity as sort of a metabolic disease. So the idea when they started out was to say, let's compare this one, case 5, normal weight firefighter cortisol levels to their 4 colleagues. This is all one crew. They ran the same calls. They worked in the same station. And I'll just make a quick note. They did include some details in the article about the shift, and it was truly hair-raising. They had 72 hours at the station, averaging somewhere between 10 and 15 calls per 24-hour shift. And the nature of the calls that they were running were the most difficult fire suppression assignments that you can get in like a residential house fire, and some of the most emotionally difficult medical calls that they were responding to. So really, truly was a good representation of a high stress environment. They also kind of zeroed in on classifying them according to their blood pressure, because this was another biometric for stress that they measured and produced some significant findings for. So here you'll see with the red arrows, their protocol for the study was every day of the 3-day shift at 8 o'clock in the morning and 8 o'clock at night. These are the values that they would measure for the participants that they felt were biomarkers of stress. Their plasma glucose, their triglycerides, salivary cortisol, salivary testosterone, and then a couple that aren't on this graph were their blood pressure as well as perceived stress. So twice a day, every day, they were measuring those values. We'll jump back and you can see, depending on what sort of like validated method you find, it's more common to measure cortisol more frequently throughout the day. But a feasibility point of not wanting to wake firefighters up in the middle of the night or distract them from their calls, they picked those 2 time points as something they felt they'd be able to accomplish for the scope of this study when measuring cortisol. So let's see. They reported their trends for cortisol for all 5 of the cases. You can see it in the paper. I chose to just put one up here because they're kind of large figures. But something I really want to point out is these slopes that you're looking at are not that diurnal response trend that we first looked at. This is just the values for their 8 a.m. readings. So the trend overall of their morning readings, and then the trend overall for their evening readings. So they have those side by side. They set a pretty specific R-squared value for significance at 0.4. So a lot of the figures, the slopes, they have really varied measurements and time points, and there wasn't always statistical significance to their slopes. But being a case series, I just kind of want to put it out there, put it in the back of your head, that idea of statistical significance versus clinical significance. So even though some of these slopes aren't statistically significant, it's still showing a pretty wild aberrancy throughout their shift. And what we can see here in this one presentation is all 5 of the cases showed a really marked spike on the morning of day 3 in their cortisol values. Even though they had an overall negative trend, they're still showing a spike on day 3. So who knows what the night of day 2 was like. But this was one of the more significant findings. This is the group averages. So within these boxes, the X's is the overall average for the 5. And this is something I'll try to point out a little bit. So we can see we have the time on the X-axis, so you can differentiate between the morning values, and they're kind of staggered with the night 8 p.m. values on top. So we have our big spike for everybody on the morning of day 3. And then if you can sort of use your mind's eye, if you were to fit a line for all of these, even the averages show sort of a decrease throughout the shift for all the participants with their averages. Now in the paper, they talked about this is what they had expected. They expected to see an overall decrease in cortisol response because as stress gets piled on, you're running out of like hormones and fats and things like that to produce the cortisol. So that was what they expected to see. And we'll get into what they actually did see sort of in the next slide. So the sort of the most exciting results that they saw were over here in the positive slopes. So a couple of the firefighters, they were expecting to see those negative slopes, and they actually saw their cortisol values rising in average over the shift. Now, a lot of these other 3 cases that showed the negative slopes or what they expected, what they actually found out was the gradient of the slope was so slight, it was almost a flat value, which is a presentation in other medical literature that they referred to as being typical of like suicide survivors. So being in a super high stress environment and not having much of a cortisol response to it. One of the things that they sort of put out for discussion as to why that might be could be correlated to years of service, how much time that you have on the job, and maybe there's some sort of adaptive response or ability to deal with stress better or different that makes that presentation so. And then just as, again, something to tuck in the back of your mind, I thought was pretty intense as well as representative of a national trend of being understaffed and having to work lots of overtime, either voluntarily or involuntary, is the number of hours that these firefighters were working within the past 30 days. Really, really high numbers. So overall, trying to wrap all this information up together in the discussion section of the article. They did have 3 out of the 5 participants showing like a normal decremental slope to their cortisol levels, but with a couple of pretty notable not normal presentations of that positive slope. They were suggesting that the spike all participants showed on day 3 really was suggestive of that overactivation or that dysregulation in the HPA axis, and they felt this was really supported by the blood pressure readings that they were taking on those 2 time points, that 8 a.m. and 8 p.m. They didn't see a dip in systolic blood pressure at the 8 p.m. measurement, which physiologically is something normal. At the end of the day, you're relaxed, your circadian rhythm is winding you down. That didn't happen for these 5 firefighters. Their blood glucose and triglyceride levels, relatively within normal limits. They didn't see any significant findings there. And then, but they did see some significance or aberrancies in their other biomarkers of testosterone, systolic blood pressure, and cortisol. One of the sort of strongest findings is that they anticipated when the firefighters would report perceived stress, they expected, hey, if there's a lot of perceived stress, that's going to correlate with high cortisol levels, and it was the exact negative. Their highest cortisol levels were associated with their lowest perceived stress scores. And then they also had sort of a hypothesis about sleep disruptions. They had them report sleep disruptions as they ran calls, and they found no significant relationship between the result of cortisol levels and sleep disruptions, with one sort of notable exception to that. One of the cases had 2 really clear cortisol value reporting. So he had one 24-hour period where he slept 45 minutes with relatively high cortisol levels. And then the following 24-hour period, he got over 5 hours of sleep and had decreased cortisol levels. So that was kind of a outlier, but interesting outlier standing on its own. So moving towards a couple of questions, or sorry, strengths and limitations. One of the strengths, or some of the strengths I felt this article had was it was really thinking outside of the box to a really high impact issue for an extreme stress population. The questions that they were asking were really derived from institutional knowledge, someone who had worked the job before. And even though they had a small population, they had a few like very interesting and arguably significant findings that could have implications that are pretty far reaching into reproducing a study like this or continuing to look at the role of the HPA axis in firefighters. Some limitations for the study, obviously small population, but even within that population, there weren't a lot of comparison points for the data that they had. They didn't have controls or comparison points, making it hard to sort of generalize it to a larger population or another study. The way that they measured their cortisol and reported it was seemed like it was something that was made up for the study. It wasn't a validated process, so it might reduce the strength of some of their assumptions from what they saw. And they didn't have baseline measurements for their stress biomarkers, the cortisol, testosterone, all those things. They showed up day 1 of the shift, measured them at those points throughout the shift, and that was the extent of the data that they had. And then there were a few reporting points, like on the blood pressure and the testosterone, that I think really could have used some figures in the paper to help report that information. A lot of it was just discussed in the discussion section, but I think a few more figures would have helped that out. And then before turning it over to the room, maybe a couple of questions just for thought. Is this enough information to attract more funding for a further study? If not, what more would you want to see or would you need to know? And then going back to the idea of this one. So we had our couple of firefighters with that like aberrant finding of a positive slope here. And they suggested maybe it has to do with years of service or some sort of adaptation to stress management. Let's run with that, right? Let's say that's the reason why. It's because of years of service. Would you consider that an effect modifier or a confounder, if that were to be the case? So, couple of questions for thought there, but any other questions y'all have?
Question before those questions.
Yeah.
They account for caffeine intake because the first responders I know drink everything to keep
Yeah.
themselves awake and keep their.
Nope, there were no like dietary controls or like nicotine or anything like that, stimulants.
Did they ask about exogenous testosterone supplementation,
Oh,
also known as gender affirming care?
gender affirming care, they did not.
And why is that a problem? Ahmed docs? You can phone an Ahmed doc if you don't know how to answer that.
Yeah, if it's a problem if they're taking additional testosterone, because I assume that would just change the hypothalamus pituitary gonadal axis and change sort of feedback loops and the way it calls for cascading.
So then what happens to the cortisol level with exogenous testosterone?
I would assume that it would decrease, but it would increase it.
But it's mucked up, right?
Yeah.
You are dumping artificial.
It's confounded. And also something that is culturally very popular within the fire service.
So, general comment, to me, this study looks like a great experience for the author to get their feet wet trying to measure these things, but it's a very clumsy measurement of cortisol. And also these are shift workers whose biological clock time may be all over the place. So measurement of cortisol should have minimum 3 measurements, probably 4, because you don't know where you're capturing. That 8 a.m. measurement could be on the upslope of the curve or the downslope of the curve. So I think 5 subjects, your question about preliminary data for funding, 5 subjects with good rigorous cortisol measurement could be enough to show that you're onto something. The 2 measurements, no. And that includes blood pressure. So blood pressure also has a circadian rhythm and should decrease during sleep. And so a single measurement time point in the evening that didn't decrease, I'm like, put an ambulatory blood pressure machine on them and then let's see what happens for 24 hours.
Right.
So I think potentially very informative mechanistic physiological measures, but just not measured frequently enough.
Yeah. And another thing for me on that point too was they didn't include details on the pacing of their call volume. So they did measure salivary cortisol at 8 a.m., but how long had they been awake for? Was that kind of back to the shift worker thing? And who knows if you're really isolating that peak appropriately.
The other thing is with the work that they do, cortisol is a disruptive thing to measure. To get the plasma, or saliva or whatever it is you're going to get from them, you have to take a moment and do that, right? Well, that's not exactly. There's not a lot of being able to control your time when you're a firefighter. Because if they're doing 10 or 15 calls a day, they aren't saying, okay, schedule your call at 10 a.m. So your next call, it's not how that works. You could call when the emergency happens, right? And so because of that, it's really hard to get a measurement like that, right? Which is why you'll see when they do biological measurement for firefighters, they're trying to do more less invasive where they have to stop, wearables or other things of that nature, because they can't necessarily stop and spit or draw some blood or whatever to get the measurement. So that's one of the reasons it's a difficult sample to be able to get enough measures to make it useful.
Right.
I would say yes and no, but because the salivary swab is pretty easy as measurements go.
Yeah.
But it's also really easy to forget and miss one.
Yeah.
And I will say salivary cortisol can be a very interesting research measure. The Work Family and Health Network had a group at Penn State that studied parents and kids, and they measured the full slope of cortisol in a 24-hour period, but on a stressful work day for the parents, it altered the pattern of cortisol in the kids. So it's like a very powerful physiological finding of not just that self-reports of stress were picked up in the kids, but the kids' physiology changed as a result of parents getting stressed out at work.
Yeah, wow.
So let's say the study gets picked up, right, to something bigger. What ultimately would you want to do with this information?
Me personally, or my my short answer is you work in somewhere dusty, you get a dust mask. My hope would be to treat stress, the occupational stress of firefighting, as an occupational health exposure, the same as diesel exhaust particulate or hydrogen cyanide from products of combustion kind of stuff.
Okay, so what does that really mean?
Resources for physical and behavioral health. So in general, on a national level, I mean, fire departments are going to, I think it's NFPA 1812, right? So pulmonary.
1582, yeah.
1582.
Yep.
So all that fitness for duty sort of stuff. But outside of that, I think there's a lot of room to grow in terms of, I think some well-selected biomarkers in this study, but maybe not measured that well. But having some like longitudinal hormone monitoring and understanding, like having resources be available for that level of stress and supporting.
So people get stressed all the time, right? Like you're probably stressed right now because I'm talking to you, right? But is it the stress that causes the pathology, or is it the maladaptation of handling the stress that causes the pathology, right? Like I'm asking you the question, and to reduce your stress, no one asks questions and no one does evaluations. Or is the pathology now that you're going to go and grab like 6 cocktails after this presentation, and then that's the maladaptive. So really understanding what the disease that you're trying to achieve. So is it the 72-hour work week that's causing stress? Is it the calls? And what, as a firefighter, can you really do to modify? Because you can't modify accidents and all that stuff, right? That's what we want. But it's the disease of like the shift work or the 72 hours on call, or is it the maladaptiveness? So really honing in what the problem is, right?
Yeah. I mean, personally, I have a lot of conspiracy theories on how what shift schedules would support firefighters the best. That's a pretty large scale thing to address. But yeah, it's like you said, the stress is there and that's part of the job, and it's difficult to avoid without doing the job at all. But I think it's about supporting a culture of change and health awareness, like in the fire service, that is starting to change quite a bit already. And I think producing research or information like this is really helpful or supportive to fire administrations to create those resources and opportunities to promote that culture of change and monitoring. And yeah, I think that's what this sort of stuff really helps.
Okay, so looking at biomarkers of stress.
Mhm.
Do you think it's necessary, or do you think someone could just tell you, I'm feeling really stressed right now with the screening tool versus bodily fluids?
I think it's necessary because with my understanding, outside of the NFPA regulations for health, it's kind of each department decides whether they want to do peer support or what sort of supportive behavioral health or health things outside of the pulmonary function tests and stuff like that. It's really up to the administration. And so if they have that concrete data from the measuring biomarkers, I think that helps them get an idea of where the benefit is to them with supporting those kind of programs for their firefighters.
Thanks.
We've got 4 minutes left. I want you to answer your second question there about effect modifier versus confounder.
Oh, for that one, it was a question I asked myself while I was reading it and had to sort of like go back to my notes. I feel like it would be an effect modifier because it's changing the strength or intensity in the direction of the relationship. But you could probably make an argument for it either way.
Model, it's no longer a confounder, right? So if they didn't measure it, then it would be a confounder, but because they measured it, then it would be part of the model and more like what you said. So anything like caffeine would be a confounder because they didn't capture it, right?
Okay.
Yeah.
There's a style of single case style research design that I'm kind of thinking about right now, that it would apply more if you were following firefighters for like a full month.
Mm-hmm.
But you could keep track of days with and without certain features and then look at the data for those days. And you just use a different marker for the days that had the certain events, call volume greater than X or stress ratings over this. And then over time, you can see if there's a separation on days with and without the treatment. It's a naturalistic treatment, but it is a way to study a small number of subjects and glean something about the effects of this type of day or that type of day.
Cool.
Side comment. I think it would be really interesting if they took a day where they weren't on shift and then measured their cortisol levels there as almost like a control.
Yeah.
If that might tie into the years of service. Like, do people who have been doing this for a very long time suddenly really higher levels of cortisol since their body's adapted to that? Or
And that could be done just like in a large populations setting rather than like super intense, multiple measurements a day sort of thing, maybe.